students, today we will study about what is Shannon Fano coding. In your previous class, you have already learned about different source coding parameters, and we have already named some source coding techniques also. Shannon Fano coding is one of those. So, what will be your takeaways from this class? After completion of this class, you will understand the algorithm of Shannon Fano code, and obviously you will be able to construct any Shannon Fano code if some source symbols are given to you. So what is a Shannon Fano coding? As you can see, it is named after two scientists, Claude Shannon and Robert Fano. So from their name, the name of the coding is given as Shannon Fano coding. It is a prefix code based on symbols and their probabilities. So what is a prefix code? Already we have learned. Just to recap, I will give you one hint that a prefix code means a code or where two different symbols will not start with the same values. So that's a prefix code. So it will be based, our Shannon Fano coding will be based on the symbols given to you and obviously their probabilities of occurrences. So it's very important in that way. This Shannon Fano coding algorithm will produce fairly efficient code, but not I will not say that it is completely efficient code. It will be fairly efficient, and variable length encoding is our primary requirement for any efficient codes. So here it suffices to that also. But as I have already said, it is fairly efficient, so it will not always produce the optimal prefix-free codes. It will be suboptimal, but not optimal. So we can say that it will be suboptimal code, which does not achieve lowest possible length, or it might sometimes achieve, but that is not the case always. So what are the steps involved if we want to construct a Shannon Fano code? The first step you can see over here, arrange source symbols in decreasing probability. So a set of source symbols will be given to you. You have to take their probabilities, which will also be provided. And from those probability distributions, you have to arrange the source symbols, keeping the highest probable source symbol on the top and the lowest probable at the bottom. That will make the decreasing probability arrangement. Now, there might be some cases where two symbols or more than two symbols also are having the equal probabilities. In that case, it is up to you how to place those. It can be placed in any arbitrary order. The second step, that is divide the set into two sets. So what does it mean? Once you have devised your decreasing order probability system, so you will have the different values or different probability values, we can say, associated with the symbols. What you do, you sum up those probability values and you try to divide that entire set into two sets such that their probability sums will be very nearly equal or exactly equal between these two sets. So that is the second step. So what is the third step? It is saying that you will assign a 0 to the upper set or 1 to the lower. Now it can be altered. You can give 1 to the upper set, 0 to the lower also. That is possible. But once you do with one technique, you have to follow that in the entire process. So that is very important. Finally, you have to repeat these second and third steps until a single symbol in a set is achieved. So these are the certain steps which we have to follow if we want to make a Shannon Fano coding. So I will give you an example how to do the Shannon Fano coding. You can see here, it is said, apply the Shannon Fano coding procedure for a DMS. What is a DMS? You have already learned, discrete memoryless source, with the following source symbols and the given probabilities of occurrence. And then it is said, calculate its efficiency. So the source symbols are given as x1, x2, x3, x4, x5, x6, and x7. What are their probabilities of occurrences? These are their probability of occurrences given. 0.4, 0.2, 0.12. Now here you can see x4 and x5 are having the same probabilities, 0.08 and 0.08. Similarly, x6 and x7 are also having the same probabilities, 0.06 and 0.06. So what is our first step? Our first step is to arrange these symbols in order of decreasing probability. Now, fortunately, we have an example where already the symbols are in decreasing probability. However, here there is an ambiguity because there are two symbols having same probability, here also the same. So you can have any arbitrary order. So let us see what we will choose. So first of all, in the first step, what we have done, we have taken the symbols as per their decreasing probability, keeping the highest probable event on the top and the lowest probable event on the bottom. So that is the first step done. What will be our second step? Our second step will be to divide this into two sets which will have exactly equal or very nearly equal probabilities. So we have done that. What we see, if we take these two events, x1 and x2, and sum up their probabilities, that is 0.4 and 0.2, it makes 0.6. So obviously the other five events, in fact, will have the probability of 0.4 if we sum up their probabilities. So we have done that. We have taken the 0.6 on the top because we are always following the criteria that the most probable event will be on the top. So 0.6 will be on the top and 0.4 will be at the bottom. And we have given the two values of the two sets of the set 1 as 0, as we have already said that we will assign a 0 for the top set and 1 for the bottom set. So this set, all of the events are having the values of 1, and here it is having the value of 2. Now we have said that we have to repeat these steps until a single symbol is obtained in a set. So here we find there are two symbols. We have to repeat the step for this set. Similarly, here it is found 5 symbols. So we have to repeat the step for this set also. So we are repeating that. So what we do, we have now divided this set into two sets, into two values. That is, one is 0 and 1. And here also, we are dividing this again into two sets, keeping that in mind that we have to make the sets in such a way that the two sets will have the same probability or very nearly equal. So here we see 0.12 and 0.08, that means it will become 0.2. Here also 0.8, 0.6, 0.06 and 0.06, that will also make 0.2. So obviously we are having the same probability. So we are dividing this into two sets. This is one set which is assigned as it is the top set for this particular subset. So it will be assigned as 0 and it will be assigned as 1. So this, you can see for this particular case, already the sets having a single symbol, so it will be stopped here. But for this case, it will be having two values, it is having 3 values, so this will continue. So here we are continuing this again with the same thing, that it is given as a 0, the upper one, and the lower one as 1. And here also again we are making the probability arrangement. So here also it is 0 and the lower one can be 1. Now we can go to the last one step. That is, obviously this is also completed. So here it is completed with a single symbol. Here there are two symbols. So we are again making this as 0 and 1. So after making all these arrangements, we can see that the entire process is completed because every set is having a single symbol. So finally, what is the code then? This will be obviously 0 and 0. So this will be 0, 0. This will be 0 and 1. This is 0, 1. This is 1, 0, 0. Similarly, this is 1, 0, 1. This is 1, 1, 0. This is 1, 1, 1, 0. And this is 1, 1, 1. So you can see over here, it is a prefix code with variable length, and whether it is a very efficient or not, that we have to check out. So what we have done, we have found out we have tried to find out the efficiency of this code. So what we have done, we have checked out what is the length of this code, average length obviously, for each bit. So it becomes 2.52 bits with this particular formula we have used. Then we have also calculated what is the entropy of this code. We have found out that with this particular formula, which already we have discussed in our previous class. So using that formula, we can see it becomes 2.43 bits per symbol. So once we have found out what is the length, average length per source symbol, what is the entropy of that, we can see what is the efficiency of the code. So efficiency is obviously 96.4%. It is not 100% efficient. However, the efficiency is very high. So this is one type of code or source code which is very often used. So with this, we come to the end of this lecture. From here on, you can think about what are the applications of this code. You can search, you can research yourself. what are the different techniques of using this code, where we will use this code, how to use this code, whether we can, if we, what is prefix-free code, how it is being related to this code. So there are lots of things which you can think about from this code. So coming to end, thank you again for using this.